This is chapter 10, lesson 7, just fractions as a whole. Okay, whole numbers can be written as fractions. When the numerator is the same as the denominator, the fraction equals 1. So what they're saying is, okay, if I have 4 over 4, if I have 10 over 10, or even if I have 2 over 2, all those fractions, if the numerator, which is the top number, by the way, and the denominator, which is the bottom number, if those two numbers are the same, it's going to equal what? 1. Look at the example. It says there are 4 panes of glass in one window of Landon's classroom. Each pane of glass is 1/4 of the whole window. So what they're saying is, this pane of glass, this is 1/4. This is also 1/4. And this is 1/4. And this is 1/4. So if I put it on the number line, I have 1/4, a fourth, 1/4, and 1/4. Okay. Okay, so it's my fraction 4/4 is equal to 1 whole. So you see how they have it represented? Here's a fraction 4 over 4 or 4/4, and they have a little drawing of a number 1. Write the fraction. So it says 1 whole is partitioned in 4 parts. So here's the whole window, and there are 4 sections, right? Okay, and then the 4 parts, the 4 goes there. So it should go 4/4 equals 1. Now it says, place a point on the number line to graph this fraction. The model shows 4/4 and 1 share the same point and have the same size. So it says, place the point on the number line to graph this fraction. So I'm graphing this fraction right here. 4 over 4. And here's my dot. Okay. The model shows that 4/4 and 1 share the same point and have the same size. So 4/4 is going to equal 1 whole. And what's the fraction? How do you write the fraction again? 4/4. So 4 is as the numerator and 4 as the denominator. Here it says the fraction 1 over 1 or 1. Yeah, 1 over 1 means 1 whole partitioned into 1 group. Okay. Either I have 1 counter in 1 group, or I have a bar that is 1 whole. However, how many wholes are in 3 over 1? Okay, so think that there are 3 parts, and the 1 at the bottom means that they're completed. They're 1 whole. So I have 3 whole circles. So 1 part, 2 parts, and 3 parts are 3 over 1. Okay, or 3 holes. There are 3 holes, or 3 whole circles, or 3 whole parts, and 3 over 1. So again, if the numerator and the denominator are the same, the fraction is equal to 1. If the denominator is 1, meaning the number on the bottom is 1, okay, the fraction is equivalent to the whole number represented by the numerator. So if I have 3 over 1, okay, that's going to equal to
1, 3.
See, so if I have 4 over 1, And I have 4 over 1. This is going to equal to 4. Okay. It's different if I have this stuff. If I have 3 over 3, or if I have 4 over 4, if I have 6 over 6, all those are going to equal 1. So look at the example that they give you. It says write a fraction to represent a shaded part each whole or set. Here, number 1, those are sets. Okay. How many parts do I have total on number 1?
8.
Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now how many are shaded in? 8. So 8 over 8 is going to equal 1. Okay. Now I have sets. Okay. Sets of wholes. Okay, meaning completed objects. Sets of wholes. Okay. How many sets are there? 4. That would be my numerator. Okay. And then number 1 at the bottom represents that there are wholes. They're not parts. In other words, this little circle, is it divided into sections?
No.
No. No, it isn't. Let's do a couple of examples. Okay. Now, number 3 is that it each whole? It says write a fraction to represent the shaded part of each whole or set of holes. So is it set of holes, or is it just one completed object, or one whole? Is it set? Are these, or is each section individual? Are they separated? Are they separated? No. No. So we're not talking about sets of holes. We're just talking about a whole object. Okay. So how many are all together in that circle? 4. How many are shaded in? 4. Number 4 though, are they talking about each hole or sets of holes? Sets. Okay. So how many sets are there? 2. That goes at the top. And then what goes at the bottom?
1.
1. Okay, you're going to do 5, 6, 7, and 8. So look at number 5. Are we talking about sets of holes or just a hole? Just a hole. How many are each section? 2. Okay, and then 2 are shaded in. Number 6, we're talking about sets of holes, right? So how many sets are there? 6. That's the numerator. Okay, and then the denominator represents 1 of each set. Okay. Number 7 is just a hole that's divided into sections. How many sections are there altogether? How many are shaded in? 8. And number 8, I have sets of holes. There's 8 sets. And 1 represents. Okay, for 9, 10, 11, 12, 13, and 14, it says write each whole number as a fraction. So I'm writing a whole number as a fraction or sets. What's the denominator? What number goes in the denominator?
1.
1. Because I'm working with a whole. And then the whole number goes at the top. So the whole number is when it's written as a fraction is going to be the whole number over 1. Because that tells me how many sets I have. And the numerator tells me that I have 4 sets of whole numbers. Okay, so this would be 2. 11 would be 6 over 1. And then obviously 1 over 1. And then 13 would be 8. And then 14 would be 3. Number 15, 16, and 17 says, find the missing numerators and denominators. Then circle the model that is not a fraction for a whole number. All right. Number 15, I have 16 total, right? 6 total. How many are shaded in? 5. Does 5, 6 Does that represent a whole number?
No. No.
Why not?
Because it's number like 6, like 5, 5.
Yeah, but why isn't 5, 6 represented as a whole number or for a whole? Because not all of them are shaded in, are they? No. So is the whole thing shaded? No. So 5, 6 does not represent a whole or a whole number. Okay. Number 16, I have four total, and how many are shaded in?
4.
Number 17, I have 3 sections, and how many are shaded in?
3.
3. It says then circle the model that is not a fraction for a whole. Well, number 18, we got 2 sections with 2 shaded in. So 17, 16, 15, 16, 17, and 18. Which one does not represent a one whole? 15 doesn't. All right. Then it says write 3 different fractions that are equivalent to 1. So if I write a fraction as equivalent to 1, that means that the numerator and the denominator have to be the same, right? So go ahead and write 3 of them. All right, so write 3 different fractions equivalent to 1. When they're equal to 1, the numerator has to be the same as the denominator. So if I have 6 and 6, okay, why don't you give me some that you write? 8 over 8. What else? 7 over 7. And then Julia? 6 over 6, or 6/6. Yeah. Does it have to be those? No. If you have 100 over 100, fine. That equals 1. If you have 1 billion over 1 billion, that equals 1. Okay. If you have Mr. Portito over Mr. Portito, that equals 1. Okay. The point is that the fraction that's equivalent to 1, the numerator has to be the same as the denominator.